So we're going to look at the leaving sorority level questions on trigonometry from the exam papers. So we'll start off with these ones here. So the first one there is 2017, paper 2, question 6. I've given that 3 stars in terms of difficulty, right? The next one is 2016, paper 2, question 2. Then 2015, paper 2, question 5. And then 2019, paper 2, question 9. So that's just what this 4 questions out of the last few years that you'll be able to look at, right? Okay, so we move on there. So the first one there that we're going to do is 2017, paper 2, question 6. So if you open up your exam papers to 2017, paper 2, question 6. So what we'll do is we'll start off by doing this question here, right? So what you need to do is you need to be able to look at it and you need to be able to decide how you're going to answer it, right? So obviously it's a question to do with trigonometry. If it's a question to do with trigonometry, you need to be able to decide what steps to take. So I'm just going to bring that in there and we'll look and see. So with this, find the distance x. Okay, so find the distance x, not scale, give your answer correct to this place. So you're looking for this side here. So we're looking for that side. We can go through our framework there. So angles in a triangle equal 180 degrees. So I can work that out if I want. But I need to decide if that's going to help me. In this case, probably won't. Well, it probably will actually. So I'm just going to work that out. So in this case, we can say that 180 minus 65 minus 63 will tell us what the unknown side is. So 180 minus 65 minus 63 gives us 52. Okay, so that'll give us 52. Okay, so I can fill that in there if I want. Okay. Next then is 90-degree triangle. There's no 90 degrees here, so that won't work. So we can't use Pythagoras, we can't use trig ratios. We have to use, next is the area of a triangle. We don't know the area, so that won't help us. The next thing is the sine rule and the cosine rule. Okay, so in order to find x, I need to decide, can I use the sine rule or the cosine rule? In this case, I can use the sine rule because I've got two opposite, a side opposite an angle and a side opposite an angle. So in this case, I can use the sine rule because the two of these are opposites and the two of these are opposites. Okay, so I'm going to use the sine rule in this case. So a over sine A is equal to b over sine B. So a over sine A is equal to b over sine B. I'm going to change that to lowercase a. Okay. So what I'm going to do this time is I'm going to put my unknowns on the left hand side. So I'm going to start off by putting my unknowns on the left hand side. So I'm going to put the pink ones on the left hand side and say x over sine 52 is equal to 10 over sine 63. Okay, when you have a fraction equals a fraction, you need to cross multiply. So I'm going to multiply two of these together and get x sine 63 is equal to, and I multiply the two of these together and I get 10 sine 52. Okay, so the next step then is to find out what x is equal to. So to find out what x is equal to, I need to divide the left hand side by sine 63. So if I divide the left hand side by sine 63, I need to do the same for the right hand side and divide the right hand side by sine 63. So from that I can check. So 10 sine 52 all over sine 63. Just typing that in there to the calculator and we get an answer of 8.844051443. It said give your answer correct to the nearest 2 decimal places. So if it's 2 decimal places, what I need to do is I need to go back 2 places. So I'll go back to there. 1, 2. I need to look at the number that follows, which in this case is a 4. So my answer will be equal to 8.84 centimeters. Okay. If this number here was greater than 5, so if that was 5, 6, 7, 8, or 9, then this would have to round up. But in this case, because it's less than 5, we just leave it as it is. Okay. So that's the first question there. The first part of that question there. And we move on, right? So part B. Okay. So again, we're still looking at 2017, paper 2, question 6, page 244, right? So the next part there is to find the distance y in the diagram shown, correct the 2 decimal places, right? So again, correct the 2 decimal places. So again, this one is fairly straightforward, and the reason why it's more straightforward is because it's just a matter of using one of the rules that we've learned, right? So in this case, we need to look at the framework. Again, the angles in the triangle add up to 180. That won't help me in this case. 90-degree triangle, I don't know if I have a 90 degree, and I can't assume that I have, so I can't use either of them there. Okay, so I can't use Pythagoras' theorem, I can't use trig ratios, because I can't assume I have a 90-degree triangle. I have to know that I have. The area of the triangle, there's no reference there to the area, so because there's no reference to the area, I can't use the area. The next thing there is the sine rule. So can I use the sine rule? In this case, I could pair up 2 of these, but obviously I have an unknown there. So if I was to pair the 2 of them, I have an unknown. That's fine. I could pair the 2 of these, but again, I have an unknown, so I have too many unknowns. If I was to pair the 2 of these, I still have unknowns. So in this case, I can pair them off. And I'm just going to highlight that just so you can see, right? So if I was to pair the 2 of them, that's fine. But in my first fraction, I have an unknown. If I was to pair the 2 of these, that would work. But again, I have too many unknowns because I don't know what this is. Similarly, I don't know what this one here would be. So I have too many unknowns, so I can't use the sine rule. So in this case, I have to use the cosine rule. Okay, so I'd be expected to use the cosine rule for this one. So I'm going to do that there and use the cosine rule, and get going with that question. I expect you to be one step ahead there. You should be trying to get on ahead of me if you can. So the cosine rule. A squared is equal to b squared plus c squared minus 2bc cos of the angle A. Okay. So you need to be able to label what you have. So we just label what we have there. We have an angle A, we have a side A, we have a side B, and we have a side C. Okay. So fill in what we have. So we have a squared. So a squared in this case is going to be equal to y to b squared is equal to b squared, which is 8.5 all to b squared, plus c squared, which is 10.2 all to b squared, minus 2bc, so b is 8.5, c was 10.2, cos of the angle A, and the angle A is 53.8. Okay, so I'd imagine most people are fairly okay with just filling in the values there, right? So let's just double check. B is B, C is that 2 times B, which is 8.5, C, which is 10.2, and then cos of the angle A is cos of 53.8. Okay, perfect. So in order to find out what that's equal to, I'm just going to fill that in, right? So in this case, when you look at it, you've got numbers plus numbers minus numbers, and this represents a number. So you could type all that straight into a calculator. And if we do, we'll end up with the following, right? So y squared is still y squared is equal to 8.5 plus 10.2, 8.5 squared even, sorry, 10.2 squared minus 2 times 8.5 times 10.2 times cos of 53.8. And if you type all that in, you will get 73.878977723. Okay. So to find out what y is equal to, we need to get the square root of that. So 73.878977723. Okay. And okay, if we get the square root of that, so just press the square root of the answer. So the square root of the answer, and that gives us 8.595288.083. Okay, so that's the value of y, and it asked us to give the answer correct to 2 decimal places. So if I was going to give that correct to 2 decimal places, what I do is I count back 2. So go back 1, 2. I look at the number that follows. If it's 5 or greater, I round up. So in this case, I'd have to round up. So I get 8.60. Okay, so because the 9 rounds up, it rounds up to 10. 10 causes this 5 here to round up, so I end up with 8.60, right? So that's the first part of that done. Okay, so the next one there is 2016, paper 2, question 2, right? So again, it's the same idea. It's relatively straightforward, right? So they're asking you to find the area of the triangle. They're giving you this information here, right? So you should know when you're given the area of a triangle. So we'll just have a quick look at the framework again. So the way the framework works is start to start, angles in a triangle equals 180. We can't fill anything in there because we don't know the other angles. 90-degree triangle, we don't have a 90-degree triangle. The area of a triangle is next, and the area of a triangle is next. It asks us to find the area of the triangle, so I need to be able to find the area of the triangle, so I'm going to do that now, right? So you know yourselves that the area of a triangle is equal to half AB sine C. So the area is equal to half AB sine C. Okay, so in order to use that formula there, you need to be able to fill in the information that you have, right? So the information that we have in this case is going to be A is equal to, well, we'll call C. So we call the angle first. C is going to be the angle, and A and B are going to be either side. So A and B are going to be there and there. So we need to fill in that information there, right? So a half AB sine C is going to be a half. A in this case is 8. B in this case is 12. Sine C is going to be equal to sine of 30. So half AB sine C is going to give us an answer of 24. Okay, and that's just a matter of filling in. So again, this is question 2, 25 marks. So the questions, if you got a trigonometry question in the first 6 questions, so the first 6 questions are short questions. If you got a question in trigonometry in the first 6 questions, they tend to be more straightforward, whereas questions 7, 8, and 9 tend to be more challenging or problem solving, right? So we move on there to the next part, part B. So part B, okay, so this is trigonometry obviously, but it's a small bit, this question is different to what you would expect from a trigonometry question. So 2016 paper 2 question 2. So a triangle has sides of length 3, 5, and 7. Find the size of the largest angle in the triangle, okay? Now, from this, a question like this came up, a similar question came up in the junior cert there a few years back, and it's all to do with understanding the basics around triangles, right? So, with a triangle, the largest angle is always opposite the largest side. The smallest angle is always opposite the smallest side, okay? So if we were to use just sketch that just so you can have an idea. So say we had this triangle here. The largest angle would be opposite the largest side. So the largest side in this case would be this side, and the largest angle would be there. Say we had a triangle like this. The smallest angle would be opposite the smallest side. The smallest angle would be opposite the smallest side. Similarly, the largest angle again would be opposite the largest side. So it's just to get you thinking in terms of trigonometry, right? So what we'll do is we'll look at this and see what they're asking us. So a triangle has sides of length 3, 5, and 7. Find the size of the largest angle in the triangle. So angle of the triangle adding up to 180 degrees, I can't use that. 90-degree triangle, I can't use that. The area of the triangle, I don't know the area of this, so I can't use that. The sine rule, in order to use the sine rule, I need a side opposite an angle. In this case, I have no angles at all, so I can't use the sine rule. So I need to look here and I need to use the cosine rule. So I'm going to quickly sketch this so I can see what I'm dealing with. So let's just sketch it like this. Again, this is only a sketch. There's no accuracy in this. It's just a sketch. So 3 is the smallest side, 5 and 7. Like I said, we're looking for the largest angle, and the largest angle is always opposite the largest side. So if this is the largest side, then the largest angle should be opposite that. So the largest angle should be this one here. So I'm going to label that X. Okay. So I've decided I'm using the cosine rule, so I'm going to just fill in what the cosine rule is. So the cosine rule is a squared is equal to b squared plus c squared minus 2bc cos of the angle A. So you need to be able to fill in that information. So you should be able to skip ahead there and fill in the next step. So it's giving you a chance there to fill that in. In this case, the angle there is going to be equal to A. So if the angle there is equal to A, then the side opposite the angle is equal to A. B and C, it doesn't matter which ones they are, but we'll just put them in there. So that's going to give us 7 to be squared is equal to 3 to be squared plus 5 to be squared minus 2 times 3 times 5 cos of the angle, which is going to be cos of X. Okay. If we're going to tidy that up, which we need to do next, we need to do it term by term, right? So I'm going to start off with the first term. 7 squared is going to give us 7 times 7, which is 49, is equal to 3 squared. 3 squared is 3 times 3, which is 9, plus 5 squared. 5 times 5 gives us 25, minus 2 times 3 is 6. 6 times 5 is 30. So I'm going to put in 30 cos x. Okay, the next step again, we're always trying to tidy things up. So we'll just tidy it up there and see 49 is equal to, I can bring two of these together. So 9 plus 25 is 34, minus 30 cos x. Okay. So we're obviously looking for a value for x. So what I need to do is I need to isolate the x terms. So I'm going to keep all these by themselves. So how I do that is I need to subtract 34 from both sides. So 49 minus 34 is equal to negative 30 cos x. So 49 take away 34 leaves us with 15. Okay. What I need to do is I need to find the value for x. So I need to get the cos x by itself. And to get cos x by itself, I need to divide both sides by negative 30. So 15 over negative 30 is equal to cos x. So in order to find out what x is, I need to get the inverse of both sides. So if I get the inverse of the left-hand side, I'll end up with just x. But I need to get the inverse of the right-hand side. So x will be equal to cos inverse negative 15 over 30. So that gives me an answer of 120. 120 degrees, right? So that gives me a final answer there of 120 degrees, and that again is 2016 paper 2 question 2. So the next one there is question 15 paper 2 question 5. Again, this one is relatively straightforward, right? So like I said to you, with the leaving cert questions 1 to 6 are all 25 mark questions. They're the straightforward ones, as in they're the ones that require, like, they're just a matter of applying what you know, whereas questions 7, 8, 9 are the ones that are more challenging because they're more problem solving based. So the questions 1 to 6 are the ones that you should be able to, they're basically just testing your skills, whereas questions 7, 8, and 9 are the ones that are testing your problem solving. I'm not 100% sure yet, but for the Leaving Cert this year, I know for the Leaving Cert higher level, there is 7 short questions, and as far as I know, there is 4 long questions. I'm not too sure about the Leaving Cert ordinary level at the minute, but as far I'd imagine it'd be fairly similar, where you're given extra the choice, right? So we'll get going with this one. So the diagram shows a triangle BCD, B to C to D. Okay, so B to C to D, and you can see that triangle there. And ABD, A to B to D. There you have it. Find B to C. Find B to C, which is this side here. Correct 2 decimal places. Okay. So we're looking for the length of BC. So just write in what BC is. BC is here, which is X. So in this case, we're looking at this triangle here, and we're trying to find this unknown side here. So let's just highlight what we have because that makes it easier to visualize. So we have an angle, we have a side, an angle, we have a side. Okay. So what we need to do is we need to think about what we have, and we need to see if we can do anything with that. So just give us 1 second to bring that up to the front. Okay. So what we need to do is we need to look and think, right? So we'll just work through it based on what we know. So the first thing we always look at is looking at a triangle, angles in a triangle adding up to 180. I can work out what this is, that's fine, but it won't really help in this case. Then we have a 90-degree triangle, Pythagoras' theorem and trig ratios, there's no 90 degrees there. Next we have is the area of a triangle, that won't help us. The next thing is the sine rule. So I need to look and see, will the sine rule help me here? In this case, I've got an angle opposite a side. Okay. They're not opposite, sorry, my mistake. I have an angle opposite a side, so we've got these two here, we could say. And the other two that are opposite are these two here. Okay. So an angle opposite side, an angle opposite side. So I can use the sine rule. So A over sine A is equal to B over sine B. So A over sine A is equal to B over sine B. And you should be able to fill that information in. Again, what I try to do is keep all the unknowns on the left hand side. So if I'm trying to keep all the unknowns on the left hand side, just tidy that up, actually it looks messy. So A over sine A is equal to B over sine B. So I'm going to try and keep all my unknowns on the left hand side. So if I'm going to keep them on the left hand side, I'm going to say x over sine of A, which in this case is 42, is equal to 16 over sine of 110. Okay. I'm obviously looking for a value for x. If I want a value for x, I'll need to cross multiply. And if I cross multiply, I'll get x sine 110 is equal to 16 sine 42. Okay. If I want the value for x, what I need to do is I need to divide both sides by sine 110. So 16 sine 42, 16 sine 42 divided by sine 110 is all equal to 11.39318.269. It said give your answer correct to 2 decimal places. So if I want to give it correct to 2 decimal places, I need to go back to 1, 2, draw my line, look at the number that follows. So the answer in this case is 11.39 centimeters. Okay. So that's part 1, or part 8. We'll finish off this question, then we'll leave it at that, and I'll leave you to do the next one by yourselves, right? So that's part 1A, part 1. Okay. We'll go on there and try part 2, or B even. 11.39 is what we just worked out. Or A part 2, yeah. Okay. So I can put in 11.39 there. Okay, so in this one, find the area of the triangle. So we already know, yeah, perfect. So the area of the triangle BCD. So again, we're looking at triangle BCD, which is this one up here. And they want you to get the area. So the area is equal to half AB sine C. I hope everyone's okay with understanding why these are relatively straightforward, because there's no real challenge, right? So half AB sine C. So in order to get half AB sine C, what I need is I need to have two sides, which I have, and I need to get the angle between them. Okay, so I need to know the angle between them. So if I'm going doing that, then I need to know that the angles in a triangle add up to 180 degrees. So if the angles in a triangle add up to 180, that means that this plus this plus this equals 180, or else what I could write is that 180 minus 42 minus 110 will give me the unknown side there. So 180 minus 42 minus 110 gives me 28. So that means that this here is 28 degrees. Okay. So half AB sine C will be a half of AB, A in this case. So obviously C is the angle, so this is going to be C. So I'm just going to put C in there. A and B are either side of it, so A and B. So half of AB sine C is going to be half of 16 times 11.39 times sine of 28. Half AB sine C gives us an answer of 42.7782488. Okay, and again it asks us to give our answer correct to two decimal places. So if we're given it correct to two decimal places, we go back two places. 1, 2, look at the number that follows, which in this case is an 8. So the answer there is going to be 42.78. And that's in meters. Okay, because this 8 causes this 7 to round up, and it rounds up from 7 to 8. So the next part there is part B. So part B is quite similar. So find the length of AB. So find the length of AB, and AB is this length here. So I'm going to just call that Y for now, because we already used X. Okay, so if we're looking for Y, we need to think and look at it and see how we're going to solve this. So you can see how these are kind of more problem solving based, in that it's not as straightforward as just asking you to use the sine rule or using the cosine rule. You need to kind of be using a bit of logic, right? So in this one, look at what we have. I'll highlight what we have first, because that makes it easier to see what we're dealing with. So we have this side, we have this side, we're looking for this side. We can work out what that angle is there. So we'll start off by saying 180 minus 63 minus 42 equals. So 180 minus 63 minus 42 is equal to 75. So this here is 75 degrees. And let's just look at that once more, just so we can see why. A straight line is 180 degrees. So from here around to here should be 180 degrees. Okay. So 180 degrees, take away this, will leave me with what's in the middle, which is 75. Okay, at this stage, you should be able to see that we've got three sides. We're looking for a missing angle. So in this case, we're using the cosine rule. It's the cosine rule. And cosine rule is equal to a squared is equal to b squared plus c squared minus 2 BC cos of the angle A. And in this case, I'm going to label everything. So I've got A is my angle always. This is opposite the angle. B and C are going to be either side. So A in this case is going to be y to be squared is equal to 10 to be squared plus 16 to be squared minus 2 times 10 times 16 times cos of the angle, which is cos of 75. So y squared will be equal to 10 squared is 100 plus 16 squared is 256 minus, okay, 2 times 10 is 20, 20 times 16, 16 times 20 gives us 320 cos of 75. Okay, so we'll tie that up. Y squared is equal to 356 minus 320 cos of 75. And again, you should be able to do the next step there. So in order to get y squared will be equal to, obviously I've got numbers and I've got numbers, so I can type all this into a calculator. So 356 minus cos of 320 minus 320 cos of 75 gives you an answer of 273.1779056, and they wanted that answer correct 2 decimal places. So if I'm going correct 2 decimal places, go back to 1, 2, draw your line. So my answer in this case will be, or sorry, y is equal to, I shouldn't have done that yet. I need to find y first. So this is y squared, so I need to get y by itself. So in order to get y by itself, I need to get the square root of that. So the square root of the answer is going to be 16.5280943. So in order to find out what y is equal to, y will be equal to 2 decimal places, 1, 2. So in this case, y will be equal to 16.53, and that's in meters.